Welcome to Algebra 2, and this is our section on logarithm and exponential functions. We're going to start today by just graphing exponential functions. Once we have it graphed, we're going to then state the domain and the range. So here's our function y equals 3 to the x. The easiest way to graph this is to just make a little xy chart here. Choose values for x, plug them in and get y. Like normal, we will go -2 to +2. So when we plug in -2 here, that's 3 to the -2nd power, which is the same as 1 over 3 squared, or 1/9. When we plug in -1, that's 3 to the -1st power, which is the same as 1 over 3 to the 1st power, or 1/3. When we plug in the 0, remember anything to the 0 always gives you 1, so that's just 1. When you plug in 1, 3 to the 1st power is 3. When you plug in 2, 3 to the 2nd power is 9. And now we're going to graph those. So when we're at -2, we're at 1/9. That's just a little bit above the x. We're at -1, we're at 1/3. 0 is at 1. 1 is at 3. And 2 is at 9. So that's going to be about one value up off of our graph here. And now we're going to connect this. Now this will never drop below the x-axis. It's going to get very, very close to the x-axis here, but it's never going to actually go underneath there, because no matter what type of value we plug in here, it's always going to be positive, because when we have that negative number in the exponent, it just makes it in the denominator, so it'll just make it a very, very small number. So here the domain. So our values for x can be anything, so any real numbers, because we can plug in any value we want to here. Our range, though, is there are some restrictions. When we take a look at our graph, we are never going to actually get 0 as an output for y. It's always going to be above 0, so y is greater than 0. This is going to be the case for every general exponential function. Now sometimes we can have the function move around, and so we will be greater than other values or less than other values, but the general function, when it's just some number raised to the x power, this will be the domain and range. So let's look at what the parent function looks like for an exponential. The parent function is f of x is equal to a times b to the x minus h plus k. H and k here, as we've learned from our parabolas, our quadratics that we've done earlier, represented the vertex. You can also view h and k as representing the horizontal translation and the vertical translation. So when you go from your starting point, how much to the right or left do you move, and how much up or down do you move? So that's what our h and k are going to be representing. We know here that if a is less than 0, that means we're reflected across the x-axis. So if we have a negative value here in front, that means that instead of having our exponential go up like that, our exponential will end up being underneath. It'll be reflected. So it'll be reflected across the x, so it'll look something like that. So that's when we have a negative value out in front. Depending on how big that a value is, if it's greater than 1, it's going to be stretched vertically. If it's less than 1, it's going to be compressed vertically. So that's talking about the stretch, the same thing that we learned about with quadratics. And then if b, the value b here, is in between 0 and 1, then it's called decay. And decay means we start up high and go low. Where growth is we start low and go high. Alright, so what we're going to do here is we're going to go ahead and graph this function. And we'll talk about the parent graph after we make the xy chart for it. And we're going to state the domain and range. So this function is going to be y equals 2 to the x plus 3 minus 5. I do want you to notice a couple things here. Our h is 3 and our k is minus 5. So that means that we are going to be starting 3 over and 5 down. Alright, so because we're doing x plus 3 here, instead of starting from -2 to +2 for our XY chart, we're going to start from -5. And the reason why we're starting from -5 here is because it's being shifted 3. So we need to look at some values that are a little bit further along. So we'll look at -5 to +1. So when we plug in -5 here, we have 2 to the -5 plus 3 and then -5. Well, 2 to the -5 plus 3 is -2. So that's 2 to the -2 minus 5. Remember that negative exponent puts in the denominator, so it's 1 over 2 squared minus 5. 2 squared is 4, so it's 1/4 minus 5. Well, 1/4 minus 5 would be -4 and 3/4. And you can, of course, use your calculator for quick work on plugging these in. So now when we plug in -4, we would have 2 to the -4 plus 3 and then minus 5. Well, that would be 2 to the -1st minus 5. 2 to the -1st would be 1/2 minus 5, which would mean this would be -4 and 1/2. Alright, so now if we plug in the 3, whoopsie, sorry about that. So now let's plug in the 3. So the 3, 2 to the -3 plus 3 minus 5. Well, -3 plus 3 is 0, so this is 2 to the 0 minus 5. Remember, anything to the 0 power is 1, so this is 1 minus 5, which is -4. Continuing on, now we can plug in our -2. So we have 2 to the -2 plus 3 minus 5. -2 plus 3 is 1, so 2 to the 1st power minus 5. So 2 to the 1st power is 2. 2 minus 5 would be -3. Moving on to plugging in the -1 then. 2 to the -1 plus 3 minus 5. Well, -1 plus 3 is 2, so 2 squared minus 5 would be 4 minus 5. And 4 minus 5 gives you -1. Okay, so now we can plug in the 0. So when we plug in 0 here, we have 2 to the 0 plus 3 minus 5. 2 to the 3rd minus 5. 2 to the 3rd we know is 8. 8 minus 5 is 3. And that's not quite off the graph, so we're going to plug in one more, which would be 2 to the one more value, which would be 1 here. So we would do 2 to the 1 plus 3 minus 5, which would be 2 to the 4th minus 5. 2 to the 4th is 16. 16 minus 5 is 11. So now we have a bunch of points, and we can go ahead and graph those on our graph. So when we're at -5, we are at -4 3/4. So here is our point at -5 and then -4 3/4. -4, we're at -4.5. -3, we're at -4. -2, we're at -3. It's -1, 1. 0, we're up at 3. And then 1, we're up at 11, which would be off of our graph. Notice that this is appearing to now go towards that value, or that horizontal line right here. Okay, and so there's our graph. Now I want you to notice that this horizontal line right here, that's at -5, which was what our translation down was. That was our vertical translation. So that's where that plus k here at the end ends up happening, is it allows us to tell us where that horizontal line is that this graph will be going towards. Alright, and then the other thing that we wanted to kind of take note of was where the k happened. Well, the k was was 3, so -3 here. And if you take a look at the graph, where we would have plugged in 0, 3 down from 0 would have been over. So this got shifted over 3, 1, 2, 3, and down 5, 1, 2, 3, 4, 5. And then right there would be your 0, 1 point, which would always hold true on the graph. Of course, making this XY chart is going to work every time, but if you understand the translation, it's going to make graphing this just a little bit easier. And so let's do the domain and range. The domain, of course, is all real numbers. And the range for this one, well, our y would have to be greater than -5. And you can usually get the range by knowing what that k value was at the end. Okay, we're going to do one more example. This one's going to be a decay example because we have 1/5. Once when we have a value in between 0 and 1, right here, that means that it's going to be decaying. So our graph should start up high and go low. All right, that's what it should look like. Now, there's no shifting here at all. So when we think about our XY chart, we know that 0, anything to the 0 power, so here we have 1/5 to the 0, will give you 1. So we know we have this value 0, 1 on this graph. And that's the point that you can usually start shifting if we do have some sort of h and k there. Alright, but we don't in this case, so we're just going to figure out what these other values should be. So if I have -1 and I want to do 1/5 to the -1 power, that means that this fraction flips, so that means we have 5 to the first power, so it's the 5th. So I'm going to have the point -1/5 here. If I do -2, 1/5 to the -2, that means the fraction flips, so I have 5 squared, which is 25. That's way off of our graph. If I plug in 1, 1/5 to the first power is just 1/5. And then if I plug in 2, 1/5 squared, well, that's going to be 1/25. So it's even closer to that x-axis, and then we can just graph it. So there's our exponential decay, and the domain here is all real numbers, and the range is going to be y such that y is greater than 0. And greater than 0 here, notice we didn't have any k to help shift it around. So that is graphing our exponential functions.